Hello friends, welcome to engineering tutorial. In the previous video, we have discussed about minors and cofactors of a matrix, that is how to determine the minor and the cofactor elements of a given square matrix. So in today's video, we are going to discuss another concept which is related to the concept of minors and cofactors and is used to determine another uh, parameter associated with the matrix, that is the adjoint of a matrix. So as I said, it is related to cofactors of a matrix. So it is actually derived from the cofactors by making some modifications, some alterations. Okay, so what is the adjoint of a matrix? Okay, what is the adjoint of a matrix? The adjoint of a matrix is actually the transpose of the cofactors. Cofactor elements. It is the transpose of the cofactor elements. Let us take a, let's say, a 3 cross 3 matrix. Let's say it is given as this. Okay, this is the matrix. Then from this matrix we determine the cofactor matrix. And how is the cofactor elements determined? First we have to determine the minor. Okay, for determining the minor of a particular element, let's say if we want to determine the minor of this first element A11, we have to omit the respective row and column. We'll remove that and determine the determinant of the remaining. I have already discussed it in detail in the minors and cofactors video, so you please check out that video before you uh, watch this video. And then the cofactor of a particular element present at the intersection of the ith row and the jth column is equal to minus 1 into I plus j into the minor of that element which is present at the intersection of the ith and the ith row and jth column. Okay, so I have discussed already these things in detail in that video. So let's say the cofactor matrix of this matrix, let's say A, is this: C11, C12, C13, C21, C22, C23, C31, C32, C33. Let's say this is the cofactor matrix where C11, C12, C13, C21, C22, C33, C31, C32, C33 are the cofactors of the respective elements. This is the cofactor matrix. Cofactor of A. Okay, the cofactor matrix of A. Now, the adjoint of A, the adjoint of A is actually the transpose, okay, the transpose of the cofactor matrix. It is the transpose of the cofactor matrix, which is C11, C12, C13. Transpose means the rows, they become the columns. Okay, similarly C21, C22, C23, so C31, C32, C33. Okay, this is the adjoint of this matrix, which is the transpose of the cofactor matrix. Okay, the transpose of the cofactor matrix. This is the adjoint of a matrix. Okay. Okay. So in the previous section we just discussed about the basic concept related to the adjoint of a matrix. So now here let us just find out the adjoint of the given second order square matrix. Okay, so first we have to determine the minor. Okay, so the minor of this element 2, which is present at the intersection of the first row and the first column, is, we remove this row and this column, so only element which is remaining is 5. So M11 is equal to 5. Okay, M11 is equal to 5. Next, M12, that is the minor of element 3, which is present at the intersection of the first row and second column. We remove this and this row and this column, that is 4. Similarly, this element which is present at the intersection of the second row and second row and first column. Okay, we remove this first column and second row, it is 3, only remaining element is 3. Similarly, the minor of this element, that is 5, which is present at the intersection of the second row and second column, we remove the second row and second column, the only element which is remaining is 2. So this is the minors. Then the cofactors. We know cofactors is given by -1 into I plus j into mij, which is the respective minor, and this I is the ith row and j is the jth column, at the intersection of which the element is present. Now C11 is equal to -1 to 1 plus 1, which is M11, which is 5, which is equal to -1 square, which is 1, so it is 5. Similarly, C12 is equal to -1 into 1 plus 2 into M12, which is 4. Now -1 to the power 3 is -1, so it becomes -4. Similarly, C21 is equal to -1 to the power 2 plus 1, which is I plus j, into M21, which is 3, which is equal to -1 to the power 3 is -1, so it is -3. Similarly, C22, the last cofactor element, which is -1 to the power 2 plus 2 into M22, which is 2. So -1 to the power 4 is 1, so it is 2. So the cofactor matrix looks something like this: C11, which is 5, C12, which is -4, C21, which is -3, and C22, which is 2. Okay, this is the cofactor matrix. Now we have to determine the adjoint of A. Okay, the adjoint of A. Now the adjoint is the transpose of the cofactor. Okay, the transpose of the cofactor matrix. So we have to determine the transpose of this cofactor matrix. So the adjoint of A is 5, the row becomes the column, 5 minus 4 and minus 3, 2. Okay, this is the adjoint of the given 2 cross 2 square matrix. This is the adjoint, which is the transpose of the cofactor. So it is very simple. First you have to determine the minor, okay, for each and every element by removing the respective row and column. Then we have to determine the cofactor by putting the formula Cij is equal to minus 1 to the power I plus j into Mij, and then after determining the cofactor matrix, the transpose of the cofactor gives us the adjoint of that matrix. Okay, so this is how you determine the adjoint of a 2 cross 2 matrix, which is quite easy because it has only 2 rows and 2 columns, so it's not lengthy. Okay.